Well, ladies and gentlemen, it's officially 6 o'clock, and so we'll begin our third session of our pesticide applicator CEU series. Tonight, we will be covering sprayer calibration and adjuvants. I'll be one of your speakers. My name is Justin McDaniel. I'm the extension educator here in McLean County. The other speaker speaking about adjuvants will be Josh Britt. Josh is with Red River Specialties Company out of Ada, and so you'll hear from him a little later. Once again, the things that you'll need for this evening will be your applicator license number, telephone number, and we will cue you to email those to us a little later in the program. To get started this evening, we're going to begin with sprayer calibration. Sprayer calibration is one of the things that is very important to chemical application, to make sure that we're spraying the right amount, stay within the label, and to do the most effective job, but still yet stay within the label and protect the environment. There are many different types of application equipment, from the ATV sprayers to the boom sprayers, boomless sprayers, handguns, airplanes, backpack sprayers, whatever it may be. There's so many different types of application equipment, but for all of those different types of application equipment, there is a way to calibrate them. While some of them are a little more difficult to truly calibrate, there are methods to do that. Anything that, you know, are tractor mounted, our airplane sprayers are pretty accurate, because it's pretty easy to maintain a continuous speed with a tractor or an airplane, really, for that matter. Where we get into difficulty of calibrating a sprayer is we get into some of these ATV sprayers or handguns, backpack sprayers with a boom on them or whatever it may be. And the reason for that is the variability that, whether it's the variability of how wide we spray, or the variability of how fast we walk or how fast we drive the four-wheeler, it's really kind of hard to maintain a real continuous speed with those. When we're walking, it could be that, you know, we find that most of the time as we are spraying with a backpack sprayer, we tend to walk a little slower the longer we walk. Maybe if we're walking uphill, we walk a little slower. Walking downhill, we might walk a little faster. That's going to impact and affect spray rate volume and application volume. So those are things to keep in mind as we go through this. But what is calibration? When we calibrate a sprayer, the objective of that sprayer is to determine the volume or weight of that application equipment will apply to a known area under a given set of conditions. So we most of the time when we look at a label on a pesticide, it's going to give us an application rate per acre or per 1,000 square feet. Typically, it's one of those. If it's something formulated for turf and ornamental, it'll be something in 1,000 square feet. If it's something for pasture and range, most of the time it's in a rate per acre. And whether that's ounces or pints, quarts, whatever that may be, per acre. And so we want to know what our spray volume is for that application equipment, so we know how to mix that properly to get the right amount of that chemical on per acre or per 1,000 square feet, whatever the parameter is. So a study that's getting quite dated now, but I think still holds true, study that was done in Colorado back in the mid 80s, showed the difference in commercial applicators and private applicators, what they thought their error was, based on their thought spray rate, what, they were polled before they were calibrated, and they asked, how they mixed their chemical, what they thought their spray volume was. And then once they actually calibrated that sprayer, what the true volume was. And they found that only about 6% of commercial applicators were only about 33% of applicators were within 10% of what they thought they were spraying, and only 23% of private applicators were within 10%. And so that means the rest of that, most were of both of those, most under applied. So they were applying less than the labeled rate of that chemical, but still pretty close for private applicators were over applying as well, 37% compared to 40 under. A big majority of commercial applicators were under applying, while only about 17% were over applying. And you think, well, that's okay, right? But the problem is, if you're not applying enough, that commercial applicator that's going out and he's not getting enough volume down means he's not getting enough chemical down. So he may not be getting a good control. So the homeowner or the producer that he's spraying for, if he doesn't get a good control, they're not going to be happy with the job he's done. He may not get that call back. Over apply, we know that that's just spending money that we didn't need to spend, because most of these pesticides have been formulated to, at the rate that they're given, will provide adequate control. So applying more, a lot of us are of that mindset that if a little bit works, then a whole lot more will work a whole lot better. But with these pesticides, it really doesn't take that. If we get it down at the right rate, over application really shouldn't be something we're concerned about. But we still see there are people that are over applying and under applying, and very few people that are hitting that target mark if they're not calibrating. Error, the reason we calibrate is because error can lead to crop injury or loss of money. If we're over applying, anything we apply, if we apply too much of it, we can even damage the intended crop that it's sprayed on. And we are spending money that we don't need to spend. So we're either losing money or we're losing performance. And either one of those are not wise investments. It costs so much now. Chemical is so high, fuel, everything else. It is not something that we really want to take a risk with. So that's the reason we promote calibration so strongly, is to make sure that we get that. Calibration allows you to determine the area, and if necessary, you can adjust your equipment to meet the label requirements your sprayer is spraying, and it delivers. If it delivers 18 gallons, maybe it requires a minimum of 20 gallons needed after we calibrate that equipment. Maybe we don't. It's important to recalibrate to make sure that you meet the minimum label requirements. Equipment that is poorly calibrated, properly calibrated, delivers the proper rate to the target pest. If equipment's not calibrated correctly, you may apply too much or too little. Either way, you waste money by using too much or not achieving control with money invested. When we talked about product registration to achieve pest management with no unreasonable effect on humans and environment, that's what we're looking to do. We're wanting to do the most effective job with no harm done to our fellow man or to the environment. For that to happen, we have to apply the appropriate amount. If you apply more, harm may occur, as well as illegal residues, and we don't want those things to happen. So the volume of the pesticide solution applied depends on several things. You know, a lot of times people think that the easiest way to change the volume applied is to change pressure. Well, pressure is probably the hardest thing to change calibration volume, because we can double pressure, but we're not going to double output. It's only going to increase a little bit. We can make big changes with nozzle selection and speed. So those two things can make a big difference in the volume applied. You know, increasing by 1 mile an hour or decreasing speed by 1 mile an hour makes a big difference. If we're going 4 miles an hour and we decrease by 1 mile an hour, that's 25%. If we increase by 1 mile an hour, that's 20%. So we can make a big difference in volume by speed. Spacing of the nozzles, most of the time the spacing of the nozzle is going to be more dependent upon the nozzle, whether it's flat fan nozzle or whatever it may be, how far apart we need to place them so that we get the correct pattern. Viscosity of the liquid, the thicker it is, the lower the volume is going to be, but most of the time that's not a great big issue with this. Sprayer calibration consists of 3 major steps. The first thing we want to do is we want to ensure that a uniform discharge from each nozzle tip. So it may be measuring each tip for a set period of time and making sure that our spray volume is uniform within 10%. If we have a nozzle that is over or under applying by as much as 10% of the total volume, then we want to change that nozzle out, because that can make a big difference in our spray pattern and spray volume. Document the sprayer output in gallons per acre, and then determine the amount of pesticide to add to the spray tank. You know, we get a lot of times, we get producers that come in and they say, well, what do you recommend to spray for a certain weed? And we tell them, you know, whatever the chemical, and they say, well, how much? And you say, 1 quart per acre. Well, how much water do I mix that with? And that is where we get into sprayer calibration. We can't tell you that number because there are so many variables that go into your particular sprayer. Are you running a boom sprayer with certain nozzles? Are you running a boomless sprayer with, you know, cluster busters? Are you driving 5 miles an hour? Are you driving 3 miles an hour? Are you running 40 pounds of pressure? Are you running 25, 30 pounds of pressure? There's so many variables for me to just say, oh yeah, mix it with 10 gallons of water and you're great, because that's not actual. That may be a good average, but it's not always accurate. And to just give you a number like that is pretty reckless. It's not very responsible for us. And so this is where we really start to talk to producers about the need for calibration, so that they know, so that they can feel pretty comfortable knowing that they are getting the best money for the investment that they're making. They're getting the best return on that money that they're spending. So the basis of calibration is determining the application rate. Application rate is a function of sprayer output and sprayer speed. Sprayer output is simply the amount delivered over time, and it's controlled by nozzle size and pressure. Sprayer speed determines area covered over time. So we're spraying a certain width, and we're we're spraying at a certain speed. And so that's going to determine that area covered over a certain period of time. So if we measure an area and time how long it takes to cover that area, we know one factor. And if we collect the spray for the same amount of time it took to cover that area, we know the output. So you've determined the output per area, and that's what calibration is. That is the basis for how we calibrate a sprayer. Some of the things that you'll need to calibrate a sprayer, you're going to need some gadgets. You need a measuring tape and markers for measuring the area of your calibration trial. If you're using a granular application, you'll want some other equipment. You'll need a scale to measure what you collect. You may need a tarp to collect the material. If you're using a sprayer, spraying water, you'll need a graduated measuring container to collect the nozzle outputs so that you can measure that volume at the end of it. But most of those are things that we all have hanging around somewhere. So nothing that you need is going to be something outrageous to find or to get. Calibrating a sprayer ensures uniform flow from all nozzles. You're going to have to determine the best operating speed to suit field conditions. Is it a pasture that the feral pigs have been rooting up? Then you're looking at maybe a 3 mile an hour. Is it been rough dozed? I mean, maybe 3 miles an hour is too fast. If it's crop land that has been row cropped, we can get up to speeds of 13, 14, 15 miles an hour, maybe even in excess of that in some of the smooth ground. So what is the operating speed? It's just going to be what best suits your field conditions. We see that's where a lot of people have a big problem. They overestimate, or they don't accurately estimate how fast they need to drive. Either they calibrate, they try to pick that speed driving up and down their driveway where it's pretty smooth, and then they get out in the field and then they realize that that's way too fast, and then they have to go slowing down. Or they try to be safe and they calibrate it pretty slow, and then they get out there and they see how slow things are going by and how long it's taking, and they think, well, I'll never get done at this speed. So then the urge to want to speed up starts taking over. So spend a little time, drive over where you're actually going to be spraying to make sure that you select a speed that's going to meet those field conditions. Select the proper nozzles. Based on the speed you're driving, they make a nozzle that will probably hit the target rate that you want to spray. So you don't have to speed up or slow down to try to get that. Once you find the speed, you can find a nozzle that will make that rate. Make sure that the nozzles are delivering at the rate that you want. And then clean all tips and screens. Especially if you're talking about a boom sprayer, those tips and nozzle screens are prone to being plugged up. If you're using a boomless sprayer, it may just be simply cleaning out the main screen before it goes into the pump. So wherever it is, but do some maintenance on those screens and tips to make sure that they're all spraying at maximum capacity and efficiency. When we're calibrating that sprayer, we want to use clean water and flush the spray system. There's no need to have any chemical in that because we're going to be handling it. We're going to be dealing with it. So we don't want to have anything that puts us in danger. If you've taken out screens and tips, make sure you replace them. Make sure that all the nozzles are the same, that you don't have a mixed matched amount or types of nozzles that's going to give you all kinds of different spray patterns and spray volumes. Check the flow on these nozzles, and you'll do that at least daily, but I would say you want to be kind of paying attention to those all the time. especially on a boom sprayer, because all it takes is one boom nozzle getting stopped up and you have a big skip set all through your pasture, whatever it may be. And then adjust the pressure. We know that pressure plays a big part in droplet size and the potential for drift. So as we increase that pressure, we reduce those droplet sizes. And as we reduce those droplet sizes, it makes coverage better, but smaller droplets tend to be easier to drift. So adjust that pressure to get the most adequate coverage without overdoing it and dealing with some drift potential as well. Here's a calibration worksheet that we've put together that is kind of simple, that we have used for years to go out and calibrate sprayers with. This one is actually kind of set up to calibrate either a boomless or a boom sprayer that goes behind a tractor. It could either be 3-point or pull type, either one, but this is kind of the calibration form. And what this does is this calibrates the course is to calibrate the square footage of 1/8 of an acre. 5,445 square feet is 1/8 of an acre. So we know that square footage. So if we know how wide that sprayer is spraying, we know how far we have to go forward to cover 5,445 feet. Once we cover that we know how far we go, we time that, we park the sprayer, and we catch the water out of those nozzles for the boomless sprayer for that period of time. And so that 5,445 square feet is 1/8 of an acre. So when we catch that liquid, we measure it in pints. And so 1/8 of an acre and 1/8 of a gallon is a pint. So however many pints we catch in that 1/8 of an acre is gallons per acre on the grand scheme. So it allows us to work with a little smaller numbers and smaller volumes, but still get an accurate prediction of what that sprayer will be able to do. That calibration sheet is, we have that. If you would like it, just when you send us an email this evening, ask for it, and I'll try to be looking for it, and I can send you a copy of it, and you're more than welcome to use it. There's all kinds of methods on the internet that you can use, but that's just one of them that we use. So that was the method to calibrate a boom sprayer, boomless sprayer. So maybe a handheld or a backpack sprayer for those guys that are spraying ATV sprayers, or maybe spraying with a handgun. The method that is commonly used is using a 128th of an acre. So 18.5 feet squared is our plot size. So we mark off a plot that is 18.5 by 18.5. Flag that off. That is the square footage of 128th of an acre. So we fill the sprayer to normal capacity with clean water. And if we're using a backpack sprayer, we pump it up to normal use pressure and spray over the plot, maintain a normal operating pressure, and record the time in seconds that it takes to spray the plot. So once we have that, once we know how long it takes us to spray that 18.5 by 18.5, we can go back and at normal operating spray volume and pressure, we can catch that in a bucket and measure that out and record that volume in ounces. And 128th of an acre, we know that there's 128 ounces in a gallon. So however many ounces you catch in that 128th of an acre is how many gallons per acre that your sprayer is spraying over a larger volume. So you can use that for your handguns. You may want to make that a little bigger. You know, if you think that that's not big enough, you want a little bigger area, you can do that. But that is one of the methods. And you may want to go over that. You can go over that 2 or 3 times to make sure that you're pretty consistent. Because if you go over it once and then you go over it again and it's quite a bit different time, you may want to do it a 3rd time just to make sure that you're pretty consistent in your time. Because if your times are not close together, then you're probably not going at a very continuous pace, or spray width or pattern or whatever may be off. And you may need to work on that until you kind of get it more accurate, so that you can maintain that over time to make sure that your calibration is right. If we get down to small volumes, trying to add small volumes to, maybe it's a backpack sprayer. For liquid pesticides, one of the things that is an easy thing to use is a plastic syringe to measure those liquid pesticides, knowing that 1 ounce is 30 cc's, roughly 29 and some change, but we typically just call it 30 cc's. So if you're looking to do a portion of an ounce, whatever it may be, you know, you can do that using a plastic livestock medication syringe. You can get those syringes in 2 cc up to 100 cc, I think. And so you can use those to help measure those chemicals, knowing that once you use them, they need to be discarded, because that chemical is pretty rough on the rubber seals in them, and you don't want to be trying to use different chemicals in them, because they're going to contain some of that chemical in that rubber seal, and so there's a chance for cross contamination. Calibrating a handheld or push fertilizer spreader. If you're using a hand spreader or a push spreader, whether it is a broadcast spreader or just a drop spreader, whichever one, you can use a 10x10 tarp. You'll need a 10x10 tarp to do that, and you'll need a cup and a scale ready to help measure that. Open the spreader to the desired setting and walk by the tarp, allowing the granules to be distributed evenly from one side of the tarp to the other. You want to make sure that when you start this process, you don't start right at the edge of the tarp, but that you start back from the edge of the tarp and you're already got the spray pattern adjusted, and it's already going to the rate you want it to be before you go over the tarp. If you start right at the edge of the tarp, you're going to have some differences in application at that point. And if you stop right at the edge of the tarp, you're going to see differences there as well. So you want to be started walking good before you go over the tarp, and walk completely over and past the tarp before you stop. Once you do that, you can gather the corners of the tarp, and all the granules should gather to the middle, and then pour them over into the cup, and then weigh that weigh on a scale that weighs grams. So if a 10x10 tarp, that's 100 feet. So there are 10 10x10 tarps and 1,000 square feet. So we take the rate and we multiply that by 10. That gives us the application rate per 1,000 square feet. Or we can take that rate and multiply it by 436 to give us the application rate per acre, because there's 43,650 square feet in an acre. So we know that we can figure out, either by that 100 square foot tarp, we can either calculate it to 1,000 square feet or for the acre. based on that and that weight. That's for a handheld spreader or a push spreader, either one. And that's applying dry granular, either insecticide or fertilizer, either one. If on the first calibration pass, you know, if you calibrate it the first time and your application rate's not enough, move the tarp to an untreated area and adjust the settings on the spreader and do it again. And keep adjusting your spreader till you get the rate that you're looking to achieve. So you want to, you're moving it around so that you're not over applying fertilizer. I mean, that's the only reason, if you're okay continuing to fertilize the same area around it, you can continue to catch it right there where it's staked down. But you want to make sure that when you stake that tarp down, that you pull it good and tight. You don't want to have it where it's waving, flopping up and down by the wind, because it's just going to throw the fertilizer that falls on it off. And you want to make sure you cover all that 10 by 10 area that you can, so that you get an accurate reading from it. Calibrating any handheld or push equipment, it's necessary that the person using the equipment be the one to calibrate it. It doesn't do any good for one person to calibrate it and then another person to take it and use it, because not everyone is going to be the same. People have a different arm span, so they're going to spray in a different width. People have a different stride length, so they're going to walk at a different pace. Some people walk faster and spray wider, and that makes a huge difference in the overall volume. You know, also don't just assume that we've got two identical sprayers, they're going to spray identically the same, or two identical spreaders that we can pull them and they're going to spread the same. That may be the case, but you want to make sure you calibrate both of them before you just take that for granted and make sure that that is the case. They should be close, but you want to, if you want to be sure, then the best way to do that is to calibrate them. The equipment for calibration, we want to mark a calibration area. The basic steps to calibrate a sprayer is: first, measure and mark a calibration area. Next, fill the sprayer at least half full. Time how long it takes you to cover the calibration area using the same technique as you would spray the product, and for that same length of time that it takes you to cover the application area, collect the spray from a nozzle. Multiply the number of nozzles on the boom, measure the spray width of your boom, and multiply by your calibration course, and you're done. That's for a boom sprayer. For a boomless sprayer, you've only got one or two nozzles on the back. You're going to collect both of those, and we'll talk a little bit more about how to do that a little later. And that'll allow you to determine the spray volume to that known area. Application rates, like we've talked about, either 1,000 square feet or acres. The units of volume will be gallons, quarts, pints, or ounces, or maybe pounds, or pounds of active ingredient. Will be different ways that you'll see this. Dry products are listed in ounces or pounds. If you're following a recommendation such as from an extension bulletin, the rate is usually listed in the form of pounds of active ingredient, not product. You have to convert active ingredient rates to product rates once you've selected the product. So make sure you understand the units that you're using. If you need to change units, make sure you use the right conversion factor for that as well. So we want to make sure read the label and watch the math. Calibration is the basis for accurate delivery of appropriate product rates to the application site. Calibration is a process used to determine the amount of product that is applied per area. Again, volume of the product per acre. So to calibrate, you must be able to measure the area and the amount of spray delivered. The first box here is 1,000 square feet, and if we apply 13 ounces to that acre area, The sprayer or granular applicator is calibrated at 13 ounces per 1,000 square feet. In turf and ornamental and pest control in and around buildings, labels are usually based on a 1,000 square feet basis, so we calibrate using units that are similar to the label. So to calibrate a piece of equipment, measure and mark an area that's 1,000 square feet, apply to that area, measure the amount applied. That's all there is to calibrating a sprayer or spreader. Second example here, we know that if we're spraying a volume of 18 gallons per acre, we can take smaller areas, say 1/100th of an acre, and find the amount, simply multiply by 100 to get that. So there are simple ways to get to that. So we calibrate your sprayer using the area basis unit found on the label. Some products are per acre, others 1,000 square feet. Like I said, for best accuracy, measure out the full area noted on the label. And if you're using small areas, then convert the numbers, because you can lose some accuracy if you get smaller. As you get smaller, there are some built-in error there. The calibrated delivery rate must be determined before you can do the calculations to determine the amount of product you're going to need for a job and the amount of spray mix needed. So we know if we're going to spray a certain rate, quart per acre, and we have 100 acres, then we know we need 25 gallons. But we don't know how much water to mix that with to make sure we truly cover all of that. Now we can know how much chemical we need to cover a certain area, but we don't know how to mix it to make sure we get that without calibrating. You know, if you're uncertain with calibration or the calculations, get someone to help you. Get someone to help you check your math or help you do it, because error equals dollars. You know, if we over apply or under apply, that's just costing us money. So don't be afraid to ask for help to make sure that you get things done right. Calibrating the equipment anytime we want to calibrate anytime we change equipment. If we change a tractor, or we change a pump, or if we change nozzles, you know, maybe we change boom height. If we change product, calibrate your equipment. If we don't change anything, we still want to calibrate at least once a season, probably more often. We definitely want to do those walk arounds where we check for wear on equipment, worn nozzles. If you're concerned about application cost or efficacy, accurate calibration is critical. Can you imagine the amount of money that you'd waste if you misapplied if you were spraying a railroad line 200 miles long and you were off on your calibration? How much money that could add up to? An error in calibration hits the pocketbook. And when you don't apply the right rate to control the pest, as we talked about, we wasted money and time. You know, a 5% variation, that's where they start talking about the need to change that. So we need to, once we start seeing a volume that is more than 5% off of the total average, it probably will pay dividends to change those. Maximizing sprayer performance. The best type of sprayer nozzle, stainless steel, probably brass, are the most common. Stainless steel is probably the best choice. Brass is probably the cheapest, but it has a poor wear life. So and it's susceptible to corrosion, especially if you're spraying liquid fertilizer. Ceramic probably is the pinnacle of sprayer material, but they are pretty fragile, but they do have superior wear life. So somewhere in the middle of that's the stainless steel, and we know that that's probably our best buy for the money. Relative nozzle wear, brass is probably the least durable, most likened to wear. Stainless steel is 3.5 times harder than brass, and hardened stainless steel is 35 times harder than brass. So those are all going to last considerably longer than that. Maximizing sprayer performance using screens and filters. If you've got 0.2 of a gallon a minute or more, use a 50 mesh. Less than 0.2 of a gallon a minute or more, use a 100 mesh. That's going to be quite a bit finer. And just making sure that we filter out any impurities in that water before it gets into that spray screen, that tip to plug it up. Nozzle designs, we won't go much into nozzle designs. Here's just some numbers that you might see. The numbers HSS 802E, HSS being hardened stainless steel, 80 means it's an 80-degree spray angle. O2 meaning 2 gallons per minute at 40 PSI, and E meaning it's an even flat fan pattern for band application. So all of those things, HSS 802E, that just looks like a bunch of numbers, but that's actually what all of that stands for. And so there is some method to the madness when you look at those. And once again, there are all kinds of nozzles out there to fit every job that you have without having to make a whole lot of change to speed, pressure, boom height, anything like that. You can find the right nozzle to fit about any job. How to choose the right nozzle size. We want to know how many gallons per minute per nozzle. We want to take the gallons per acre times miles per hour times the nozzle spacing divided by 5940. And that will tell you what the gallons per minute need to be. And then you can select a nozzle that fits that. We'll skip over some of that. Finding nozzle capacity in the manufacturer catalog. You can find the right nozzle for that. How to change sprayer output. Like we said, the nozzle is the best way, best for large changes in output, because the other large way to change output is speed, but most people don't want to slow down to put out more spray. And sometimes speeding up probably is not an option, because we're already running as fast as we can run, because we're trying to cover as much as we can. So we can't go any faster, and we don't want to go any slower. So those are the ways to change output, or change sprayer output with speed. But nozzles, we can do that and never change our speed. Nozzle rates. Nozzle rates are dictated by the variables that affect spray rates are nozzle flow and speed of travel. So we can break these two down a little further. Spray rate. Increasing the size of the nozzle opening will allow more liquid to pass through the nozzle. At this point, it might be beneficial to talk a little bit about nozzles and how they are identified. When a company makes nozzles, they design them to put a certain amount of liquid out over a specified amount of time. Although there may be some manufacturers that might identify their nozzles in a different way, many measure rate by gallons per minute. A manufacturer's quality assurance will work to be consistent in this output at a specific pressure. in the nozzle example that we have here, it's identified by the XR 8003. What does that mean? It means that this is an extended range nozzle, a model name that gives you some information about the nozzle. In this case, this nozzle holds its pattern in an extended range of pressure. However, 8003 provides two bits of information also. The first is that the nozzle is an 80-degree pattern angle in which affects the boom height. The second is that it will put out 3/10 of a gallon per minute at 40 psi. The 40 psi is something that will be specified by the manufacturer. Knowing the amount of volume a nozzle put out in gallons per minute will become more important when we discuss the actual calibration of the actual application equipment. So the nozzle flow rate is affected by your operating pressure and the size of the nozzle openings. Increasing pressure using a nozzle with a larger opening will increase the flow rate. However, increasing pressure will not give you a proportional increase in flow rate. For example, doubling the pressure does not double the flow rate like we talked about before. Rather, you want to increase the pressure fourfold to double the flow rate. Therefore, pressure cannot be used to make major changes to spray rate. Keeping in mind that operating pressure must be kept within a recommended range for each nozzle type to obtain a uniform spray pattern and to minimize that drift. Adjusting pressure is good for small adjustments of flow. However, for larger adjustments, consider changing the nozzle altogether so that we can stay in the right rate. The second variable that affects spray rate is speed. Changing the speed of the application equipment is another way to make large changes in spray rate. The nice thing about changing speed is that it's a one-to-one relationship. Increasing your speed two times from 5 miles an hour to 10 miles an hour, divide your output by 2 from 20 gallons to 10. This is an easy way to make changes in output. However, speed is often determined by the equipment you're using and conditions of the location, like we're talking about. So we're already spraying fast as we can go. If you're spraying 5 miles an hour and you can move to 10, probably you've did that. So most application equipment have speedometers of various kinds. However, mechanical slippage and wear and tear that computer systems may not pick up can lead to inconsistencies in speed. It's always a good idea to check your speed once in a while to confirm that accuracy. If it's muddy and tires are slipping, spinning, that's not being reflected on how fast you're moving forward. Okay, to measure ground speed, stake out a distance between 200 and 800 feet. It's best to use this condition similar to your spray location. So if it's got hills on it, if you're going 5 miles an hour or less, you can use 200 feet. If you're going faster than 10 miles an hour, you probably want to use 800 feet. Fill the tank with water so that you get the same lag from uphill and downhill. Both trips using the average time in seconds. Plug the numbers into that equation. The distance of feet divided by the time in seconds times 0.68. 0.68 is a constant that converts feet per second into miles per hour. And it's important that you use feet and seconds in your measurement when using this equation. If you're using feet per minute, then the constant will give you a wrong answer. So if you've covered the variable that affects spray rate, we've been introduced to a little math, calculating ground speed, so we can move a little more into the actual calibration of the spray equipment. Pressure, like we said, is the only true way to do that. Spray and accuracy. New tips we shouldn't see, very accurate. If we got new tips, if we got worn tips, we may see higher volume in certain places and drier areas in certain. Damaged tips, we may not be getting any in certain places and flooding it out in other places. So we want to make sure that that sprayer is spraying an accurate pattern. One of the ways that we can do that is turn that sprayer on over some dry concrete and watch what the pattern looks like. If you're seeing dry areas in that, or areas that take longer to fill in, then that gives you an indication where your worn nozzles may be. If you have certain different types of nozzles, flat fan nozzles, they need to overlap. So you don't want them spraying edge to edge. They need to overlap by 30%. From the edge of overlap at least 30% to the edge of the other pattern, to make sure that you're getting that proper volume out in the middle of those tips. We see a lot of people that use a GPS and they think, well, why do I calibrate? I've got one of these. For those of you that have an application control system that helps maintain spray rate, speed is also maintained by various mechanisms, but we still need to calculate the amount of product to mix in the tank. So it may tell us an accurate spray width, speed, but we still got to know the variables to know how much to mix into that tank to get the right application rate out. Why do I calibrate? Why do I check this? Because equipment does wear out. Maybe it's even off. Sometimes computers can be wrong. There are things that impact even GPSs, hills, rough terrain. As a tractor shifts, it'll have some impact on some of these, depending on the type of satellite antenna that you have. So it never hurts to check that to make sure that it's right, and just gives us the peace of mind of knowing that it is. Just because the machine gives you an answer doesn't mean we have to just blindly accept that. Just because it says turn right, if it's going to take you off a cliff, we need to be careful about that. There is some math, and you've guessed it, you need to be able to do some basic math to be a certified applicator. You need to know how to multiply and divide. You need to know how to multiply fractions, do ratio calculations so you can calculate the correct amount of product and spray mix. Some spray guides and reference material have formulas to assist you with this, but make sure your units and calculations are accurate when you're using these formulas to make sure that you're doing them correctly. Unfortunately, not every field is square. So if you're working with something that is irregularly shaped, if we don't know what the area is, a lot of times we can use there's new technology now. Google Earth is one that you can use very, very readily, and it has a way that you can actually measure the square footage in the area of any kind of shape based on an aerial view of that area. It'll tell you how many acres it is. And so not every place is an exact acre and in a square. So how much of this is an acre? So if there's 2,595 square feet, and we know that there's 4,300 43,560 square feet an acre, then that is 0.06 acres. So it is a very small part of an acre. But if it's in 1,000 square feet, that's 2,500 square feet if you're working with turf chemicals. If you have a weed problem in a 40 by 300 turf area, the herbicide label says apply 4 ounces per 1,000 square feet. How many ounces of product do you need to comply with the label? So the first thing you do is you try to find the area. 40 feet times 300 square feet is 12,000 square feet. So if we have 12,000 square feet and we're going to put 4 ounces per 1,000 square feet, so we take 12,000 divided by 12 and we get 12 units. If the label calls for 4 ounces per 1 unit of 1,000 square feet and we have 12, we multiply 4 times 12, so we need 48 ounces to cover that treated area. So it doesn't have to be difficult. Many times we need more than a tank load to spray, and you have to calculate how much product you need per tank load. In order to do this, you have to determine how much one area tank load covers. So we have a sprayer calibrated to deliver 20 gallons. Your sprayer has a 300-gallon tank. You need 2 quarts per acre. How many gallons of product do you need to fill the tank? So how many acres? First thing you want to do is see what area this will cover. So if you got a 300-gallon tank, you want to divide that by 20 gallons per acre to know that this thing will cover 15 acres. And if we're going to put 2 quarts per acre down, now we know that we have 15 acres, 2 quarts per acre, we're going to need 30 quarts. So if we have 30 quarts, we know that a gallon is 4 quarts. So we divide the 30 quarts by 4 quarts per gallon, gives us 7.5 gallons. So to put 2 quarts per acre down at a spray rate of 20 gallons per acre in a 300-gallon tank, we need to put 7.5 gallons of concentrate in our 300-gallon sprayer, and that should cover 15 acres at 2 quarts per acre.
Okay, we're going to go ahead and get started on this second half, try to get this series completed. For those of you that are joining us that haven't in the previous 2 sessions, my name's Josh Britt, and I'm the area manager for Red River Specialties in Ada, Oklahoma. Tonight I'm going to be talking about surfactants and adjuvants. First slide here is going to be understanding surfactants and how to choose the right surfactant. The most expensive surfactant is the one you, or the most expensive spray is the one you have to do twice. For people that are in this business, you have to go back and do a reapplication for breakthrough or whatever reason it is. Most of the time that application's on you. You've already bid it to do it the first time. If you have to do it a second time, that's coming out of your pocket. So the most expensive spray is the one you have to do twice. Next slide here, protect your investment in the herbicide. You see this nice Corvette car, all decked out. Expensive car. Why in the world would you want to put some kind of cheap tires on it? Kind of like this next slide here. You know, is your high performance pesticide riding on a cheap adjuvant? You see these wagon wheels on this other car here. Your surfactant, the quality of surfactant you use is going to determine whether your your pesticide or your herbicide, whatever you want to call it, is performing like it should. Just an overview of what we're going to cover. Adjuvant terminology, adjuvants 101, water conditioners, drift controlled products, new adjuvants, and maybe some useful websites. First question I get asked, are adjuvants registered? Not by the federal government, they're not. The EPA has an exemption for them. But they do, as you see here, some states do require registration. Oklahoma's not one of them. Arkansas, California, Idaho, Kentucky, Mississippi, Tennessee, Utah, Wyoming, and Washington. I also believe not California, but New York has started requiring some adjuvant registration. Council of Producers and Distributors of Agrotechnology. They do an ASTM or CPDA certification. These are some certification companies that certify these products. What is ASTM? It's the American Society for Testing of Materials. Here's some terminology that you might see when it comes to adjuvants. I'm not going to go over each one of these specifically, but these are terms that you will see when referring to adjuvants or surfactants. The definition of an adjuvant, though, is a material added to a tank mix to aid or modify the action of an agrochemical or the physical characteristics of the mixture. There's some more terminology. If you have a question at the end, we can come back to these terms, or I can send you this slideshow, whatever, because it has a lot of information that I'm going to go over quickly. A lot of in-depth information that some of it be like reading a herbicide label. Let's go ahead and discuss a couple of these because you'll see them again. Adjuvants, there's going to be some drift reduction agents. There's going to be some defoamers. Petroleum, vegetable, and paraphenetic are going to be different types of surfactants. MSOs, surface active agents, which is what a surfactant is, reduces surface tension. Moving right along, we're going to go ahead and I'm going to pull this picture up. I hear this all the time. Adjuvants have had a bad rap in the past. People say it's snake oil. It doesn't, it's just something to take my money. And that couldn't be further from the truth. These products really do aid in helping the efficacy of your herbicide. Adjuvants continue an upward trend, minimizing off-target spray drift and spray volatilization is one of an applicator's most important things they can do. Many would argue the most important aspects of their day-to-day. We see a lot of lawsuits nowadays for off-target applications. And I'll get to that later in the slideshow. But these products are probably some of the most important. Spray applications are affected by many physical variables: UV protection, mixing, pesticide stability, solubility, compatibility, foaming, suspension, spreading, buffer, droplet size, deposition, drift, volatilization, coverage, sticking, penetration. Surfactants, also called spreaders or wetting agents, an adjuvant that reduces surface tension between the spray solution droplets and pest target surface, thus providing greater coverage. Methylated or ethylated seed oils is that emulsified methylated or ethylated seed oil, acts as a penetrant, acts as a spreader, and humectants. Water conditioning agents, they reduce the antagonistic effects of impurities found in water in a water carrier, potentially greater pesticide efficacy results. I'll pull up a water conditioning agent later in the talk, and basically where we see the biggest problem of antagonistic effects is glyphosate in hard water. The harder the water, that molecule and the glyphosate tends to be antagonized by the hard water minerals and affects the efficacy of glyphosate. That's where we see the biggest effect. Deposition aids reduce the amount of fine spray particles that carry pesticide out of target areas. What we see a lot of times is on a deposition aid, it will itemize the microns to a more uniform size to allow them to hit and spread versus bounce, and they penetrate that canopy, the vegetation canopy, to get further down inside some of the smaller growth. They also reduce evaporation of the spray droplet used during high temperature, low humidity, and low spray volume situations. Drift control agents reduce the amount of fine spray particles that carry pesticides out of target areas. They're similar in makeup to deposition aids. Defoaming agents suppress foam of various pesticide solution and aids in filling tanks. The terms adjuvant and surfactant are both used in our daily spray discussions. Surfactants are actually a specific type of adjuvant. All surfactants are adjuvants, but not all adjuvants are surfactants. Think of pesticides. They're a broad term, whereas herbicides, insecticides, and fungicides are more specific. Okay, surface tension. We want to know surface tension is a condition that exists at the free surface of a solution. This is where I was telling you it gets really scientific. This is how we test surface tension. In the labs, when we have these surfactants tested, they run them through a series of tests, and they're measured in dynes per centimeter. It's going to take somebody a whole lot smarter than me to explain just what all that stuff means, but I wanted to include this slide. Guy that used to work with us gave this to me. People are always asking, well, how do you know how good it is? Well, because it was tested on something just like this. Just take my word for it. This shows surface tension of an insect on water. It's not sinking. All four of its legs are on top of the water. I think that's pretty cool. Here's a Draves wetting test. Correlates to how well a pesticide solution will wet and spread on a solid surface. For example, plant, weed, etc. This standard method test measures the time in seconds it takes to wet a woven cotton piece of material. Excuse me. A superior wetting agent at 0.25% volume to volume concentration will require less than 20 seconds for wetting to occur. Untreated water measures at less than 300 seconds. This one did it in 7. So what does all this mean? Adjuvants aren't snake oil. Adjuvants are on the label, and the pesticide label is the law. Adjuvants help to increase herbicide performance. Basics are not supporting claims without recommended adjuvants. Surfactants are the most common and widely used type of adjuvants. The term surfactant was coined from the phrase surface active agent. 90-10, 80-20, 100%. What do the numbers mean? I get this all the time when using surfactants. Oh, I need an 80-20 or I need a 90-10. And to be perfectly honest, the more I've studied about it and the more I talk to people, the more I figure out that most of the time they don't realize what they're asking for. And this next slide is going to show you some common surfactants. Probably the first 3, the alcohol ethoxylates, are probably one of our most popular. The first 3 mentioned here are probably going to be your most common surfactants, and their active ingredients. The most, like I said here, the most common that we use in the tank are going to be these 3. Surfactants, fatty acids, xyl alcohols, water, polyethylene glycols, and defoamers. This is where we're getting to the meat of the surfactant talk. We're going to talk about a 90-10 non-ionic surfactant for just a moment. The adjuvants sold as a non-ionic surfactant are typically categorized as 90-10s, 80-20s, or 100%. This means the product has either 90% active ingredients or 80% active ingredients. That is not what we're calling the surfactant load. A lot of people think that's a 90% surfactant load or an 80% surfactant load, but that is not true at all. Active ingredients include defoamer, solvents, fatty acids, mixing acids, and the actual surfactant. A product described as a 90-10 surfactant does not mean 90% surfactant load, but rather the amount of all active ingredients. It is very important to understand the level of actual surfactant ingredient that is contained in the product to determine the level of quality and performance. You can have a 90-10, like over here in this example, you can have a 90-10, which is 10% water, which is your inactive ingredient, 5% solvent and defoamer, 15% fatty acids, and 70% surfactant load. 90% active ingredients is your total. Both products A and B in this example would be properly sold and labeled as an 80-20 NIS adjuvant in both in the marketplace. Both products have 80% active ingredients, but if you notice right here, one of them has a 40% surfactant load, the other one has a 20% surfactant load. So you really want to pay attention to this when you're buying a surfactant. Our Red River NIS that most of you that are applicators that work with me buy, it usually has around a 70% surfactant load. Our Champion is a little bit higher than that. In this example, product A has 2 times as much surfactant, the ingredient that actually gets the job done in the spray tank. It is important that our customers understand the difference in the product quality and the value difference in different surfactants. Surfactant load is a measure of the exact content of true non-ionic surfactants in a particular product. Expressed as a percentage, a product with a true surfactant load of greater than 70% or less than 70% may not meet the requirement for an adjuvant as specified by some pesticide manufacturers. A trademark product here, it's Wetsit, a versatile wetter spreader and penetrant for use of pesticides and foliar nutrients on right-of-way and field crops, and it is CPDA certified. It's called a do-it-all adjuvant to make adjuvant selection easier and inventorying multiple adjuvants unnecessary. At low rate, it provides excellent spreading and wetting for contact pesticide applications. At moderate rates, its proprietary phloem technology provides rapid absorption into the leaves, quickly delivers into the leaf quickly, and delivers systematic pesticides or nutrients into the plant's phloem for translocation. But if you'll notice on this next slide, it's CPDA certified, but the surfactant content is only 8.15%. So things that you really need to pay attention is the actual surfactant content. Adjuvants. Post-emergent applications of habitat herbicide require the addition of a spray adjuvant. We're using habitat as an example here. Only spray adjuvants that are approved or appropriate for aquatic use should be utilized. When you're doing a aquatic application, although the herbicide you're using is aquatically approved, you need to make sure that any adjuvant or surfactant is also approved for aquatic use. Non-ionic surfactants use a non-ionic surfactant at the rate of 0.25% volume to volume or higher of a spray solution. 0.25% volume to volume is equivalent to 1 quart in 100 gallons. It's 0.25%. For best results, select a non-ionic surfactant with a HLB ratio between 12 and 17 with at least 70% surfactant load in the formulated product. Alcohols, fatty acids, oils, ethylene glycol, or diethylene glycol should not be considered as surfactants to meet the above requirements. You always got to pay attention to these things on your product label. Methylated seed oils or vegetable oil concentrates. Instead of a surfactant, a methylated seed oil or vegetable-based seed oil concentrate may be used at the rate of 1.5 to 2 pints per acre. When using spray volumes greater than 30 gallons per acre, methylated seed oil or vegetable-based seed oil concentrate should be mixed at a rate of 1% of the total spray volume. That's V to V. Or alternatively, use a non-ionic surfactant as described above. Research indicates that these oils may aid in habitat disposition and uptake by plants under moisture or temperature stress. Silicone-based surfactants. And again, we're talking about specific surfactants for habitat. This is just, for example, see manufacturer's label for specific rate recommendations. Silicone-based surfactants may reduce the surface tension of the spray droplet, allowing greater spreading on the leaf surface as compared to conventional non-ionic surfactants. However, some silicone-based surfactants may dry too quickly, limiting herbicide uptake. Invert emulsions habitat can be applied as in invert emulsion. The spray solution results in an invert water and oil spray emulsion designed to minimize spray drift and spray runoff, resulting in more herbicide on the target foliage. The spray emulsion may be formed in a single tank, batch mixing, or injected inline mixing, but you always want to consult that particular label. What's in your water? This section is where we're going to talk about some water treatments. An active ingredient application will never be better than the mixing water that you begin with, no matter what the water source. Why is water quality important? If we were in person meeting, and I would open this up for questions and kind of a chat, so to speak, because in our business, I deal with a lot of different water sources. I talk to different applicators. Some of them actually collect creek water, some pond water, some well water, some rural water, treated water, non-treated water. So there's a whole different scale of different types of water we use. And for the most part, different applicators know their water sources, have probably had them tested or test them themselves, or they've noticed their application quality isn't what it has been in the past, so they go to looking for reasons and they find out that it's water quality. So water is used as a primary carrier for crop protection product applications, constituting more than 95% of the spray volume. The properties of water used for carrier and spray solutions can greatly influence the performance of the herbicides, including glyphosate, 2,4-D, detail, and many other herbicides. Most common water issues are the pH levels, the hardness levels, the turbidity, and the temperature. Here's a little picture of a pH of common substances. You can look at battery acid, lemon juice, vinegar, orange juice, blood, seawater, ammonia, bleach. These are all the different pHs from 1 to 14.0. This is showing a map of the US and how hard the water is. In the Midwest here, or I would say the central United States, we have a little bit of everything. We have some yellow down here in Oklahoma, which is slightly hard water, to hard water right here in most of the state. You get farther north into Kansas and Nebraska, you see very hard water, moderately hard water. We have a little bit of blend of everything here in the central part of the US. So that just gives you kind of an idea of what our water here in Oklahoma is. Hard water classification or concentrations. The WHO, you have parts per millions, the WHO water classification, 0 to 114 is soft, 114 to 342 is moderately hard, which is what you're going to see in Oklahoma. 342 to 800 is hard, and greater than 800 is extremely hard. If you've ever bought a water conditioner off of us, something called Elite Imperial, you will see we send, well, I don't know if we still do, but for a few years we sent these water test kits in a box with our adjuvant Elite Imperial. It contains a liquid AMS, and it's to treat water. Turbidity. Don't use dirty water. Dirty water affects your tank mix by binding to the herbicide and lowering its efficacy. Soil and organic material can also block nozzles, screens, and reduce the delivery of the product. I believe Justin mentioned about block nozzles and screens earlier in his talk. It affects your calibration spread, and it also affects the job you do. Applicators must avoid using cloudy or murky water for herbicide applications. That's kind of a common sense comment there. Temperature, hot and or cold temps can affect herbicide performance If possible, don't leave tank mixes overnight. Here's some different products that water affects terribly. The hard water, detail glyphosate, 2,4-D amine. Some of these are really popular with all the applicators that are on here tonight. You got some SUs over here, picloram. So extremely hard water is terrible. Extremely low water quality is terrible too. It just depends on what you're using. Here are some different water conditioners. Elite Imperial, this is the one I'm talking about. It's a liquid AMS. We also have a RRSI liquid AMS plus defoamer, or you have the old faithful 50-pound bag of dry ammonium sulfate. This next slide is going to show you why you want to get away from the 50-pound bags, because it takes so much more product to equal one bag of that. But here's a nice little depiction of all those bags of dry EMS. Elite Imperial, this is one of my favorite water conditioners that we sell. It's a great product. We've sold a lot of it. It's just a liquid AMS. Here's a pH chart and how you determine how much you use and what effects it has. A pint per 100 gallons. You're looking at right here. About lower it to about three and a half. Imperial is a water conditioning agent which promotes herbicide performance by modifying elements such as pH and hardness of the spray water. Low use rates, 2 quarts is equivalent to 8.5 pounds of the old dry EMS. 4 quarts is equivalent to 17 pounds of AMS. So you can see how the liquid greatly reduces bags of AMS. Contains a source of nitrogen, AMS, 1/3 of the formulation. To aid in herbicide uptake, a blend of ammonium sulfate and ammoniacal nitrogen have been added, along with buffers, sequestering, and chelating agents to condition the water. Hard water and high pH can minimize the efficiency of certain pesticides. Ammoniacal nitrogen is known to be an effective uptake enhancer for herbicides by several plant species and by conditioning the spray water and providing a source of that nitrogen. Getting into more science here, I've got several more slides to go through, so I'm not going to get into all the scientific stuff. If you would like I said, if you'd like a copy of this to where you can study it a little bit closer, I'd be happy to share this with you. It really is informative. Unfortunately, I just don't have the time to go into the molecules and the scientific side of it. Just showing you some of the science behind these surfactants. Hard water reducing performance. It's evidenced in the spray tank as a cloudy haze where hard water minerals complexed with herbicide disrupt the solubility and dispersion of active ingredients into spray solution. If you look at this picture, you can see soft water and herbicide, and then on the right you see hard water and herbicide. It makes a huge difference. Conditioned water and active ingredient mixed into clear solution in jar 2. I'm going to show another little quick video here, just a few seconds, and it just kind of gives you a little perspective. So as you saw in that video, it's amazing what a water conditioner can do. And you can see it right there in front of you on that little scientific experiment. Drift reduction technologies, additives. This is going to be a brief history. I don't know if any of y'all remember the old DDT. We'll just go to ASTM definitions of drift reduction technologies. Drift reduction agent is a material used in liquid spray mixtures to reduce driftable fines. Deposition aid is a material that improves the ability of agrochemical sprays to deposit on targeted surfaces. Driftable fines is the percent volume of spray droplet size distribution that is under 105 microns. Why interested in drift? Gives you spotty pest control that drifts, wasted chemical, off-target damage, results in higher cost, chemical trespass, litigious society. You know, we live in a society that wants to litigate every little problem you have. So we want to stay away from that. Timing, is it windy? The environmental impact on water and air quality. If you don't have drift, you get better performance. This guy right here, I want to show you this short little video. I hope the sound works. But it's going to show you, this is a vineyard in California, I think. Or no, this might have been in Arkansas is where it was, but it was a drift on a vineyard, and I'm hoping this will play, and it gives you a little idea of off-target drift.
We're at 200 Belash Avenue, and we observed herbicide damage on our grapevines that are here at the location. We have found out that the railroad applied chemicals on March 24th. Now, this is evidence of herbicide damage. The applicator applied Roundup, glyphosate, and a chemical that we refer to as Transline.
And what do we see here? What's happening to the run?
We have a lot of cupping, distortion of the leaves, distortion of the growing tips.
So this is the normal leaf is closer to this one, but these ones have closed up and
Yep. You got a bunch of glyphosate, Roundup, in your vineyard. You got a bunch of copyrolid in your vineyard, right here. So what do? What, you know, my time clock is still clicking to harvest there. Okay. What we do? Look at the timeline of when the grapes are going to be harvested, and we run as long as we can and still get a grid sample results to them. Because vines are like humans. Have you ever had a virus that you couldn't shake? What did you do? You went home and just let it run its course, right? Vines are the same thing.
So you see that that fella, he got an off-target application. I would say that in theory, it looked like he was awfully close to the railroad right away, but there was a chemical trespass on his grape vineyard. So that's something that he's got to deal with now, and so does the railroad. Here's another article about a farmer killed during an argument over herbicide. That happened in Arkansas. And the guy ended up dying. So is drift really something that you want to deal with? Do you want that litigation? Do you want that financial burden? Not to mention, it's just not good stewardship. There's some more. There's another case under scrutiny. I mean, here's a claim that totaled $20 million filed by 200 growers. I mean, don't get me wrong, this is in the Western United States. It's a lot worse out there than what we're seeing, but we're seeing a lot of dicamba claims in Arkansas over drift when the use of a drift control adjuvant could have worked, or just like we've talked about in earlier sessions, just reading the label and watching the weather and the timing. Temperature inversions will get you some claims as well. Here's another farmer claims from Wilbur Ellis farmers. They paid $3,000 to $2.2 million in claims. Elite Velocity is another product that we have. It's a drift control agent. It's not necessarily a surfactant. It's more of a deposition aid and a drift control agent. If you'll look at these light spots right here on the leaves, this is another video that's really cool where you can actually see a water droplet hitting a leaf. And then you can also see the Elite Velocity treated water drop and how when it hits the leaf, it spreads instead of bouncing off. So I want to play it. And this is an example of a drift control and deposition aid. If you notice that it was the Elite Velocity stayed on that leaf, the plain water just bounced right off. Velocity, and this was ran in a wind tunnel test. It was really cool to see how it tested out. So some of you people that that love the science, I want to leave this up for just a second, but these are the different parameters that they use, the nozzles, the wind speed, they measured it. And they also measured the microns. Like I said, if you're scientific, this is really, really cool information. It was really cool to see this test administered. But this is, like I said, this is a drift control agent. If y'all are in need of something like that, Velocity is an amazing product. These are some different herbicides that we used it with. PSI that we used, the wind speed that it was tested at, how many ounces we used. It was a really neat test. Different nozzles we used. The take home we got from all that scientific result was those scientific results were many factors can influence drift reduction technology performance. The type of nozzle you're using, the tank mix you're using, the pressure you're using, the wind, humidity, heat, rain. Adding velocity reduces the number of driftable fines. If an applicator or pilot is not seeing a difference, you need to adjust the rates of velocity. Through university testing, various nozzles, helicopter, ground, and aerial, we always see a reduction in fines when adding a DRT such as velocity. This is another video I'm going to show you if I can. I don't know why that keeps popping up. But this is another video. The one on the right, the picture on the right, is going to be with no adjuvant, drift reduction adjuvant technology used. The one on the left is going to include velocity. So this will give you a good idea of what it does as well. you can see a huge reduction in the driftable fines. Just some little videos there. Some other, I'm about to run out of time, so I'm going to go through this quickly. A few other things that we can consider adjuvants are dyes. We have some really great dyes. Elite Splendor is one of our most concentrated dyes. You can use it for algae growth regulation in ponds. You can use it as a spray pattern indicator that helps you do a more even application. But this is some of our dry dyes in a cool little video. Shows you how well they mix. It shows you how quick our dye goes into suspension when used. Just thinks that's a really cool video. But a lot of people don't consider this adjuvant or a usable product. It's a great product, like I said, to see your spray pattern, to see where you've been, but has no control qualities whatsoever. Elite Knockdown is a defoaming agent. This was a skidder test we did. It was like a 500-gallon tank. I've visited with a couple of you guys about a defoamer, and some of y'all have used this Elite Knockdown. This is the video that I've mentioned forever, that I've looked for. I finally found it. It's on this. I've got it on one of my talks now, and I'll show you how well just a cap full of Elite Knockdown works on terrible foam. It did work on a certain mix with a injection container, but pouring it in over the top on this foam worked really great. So I want to show it to you. That was one cap full, and that was some extensive agitation, and it still knocked it down like crazy. It's an amazing product, but you see a lot of times foam when you're using 2,4-D and a non-ionic surfactant, you'll see a lot of foam. Sometimes you'll see a lot of foam with a glyphosate or a SU. Plotter, Patriot, Escort, you'll see those foam. So a defoamer is often a good investment. And then another surfactant technology we have is odor reduction technology. There's a lot of harsh smells that are associated with certain herbicides, such as pendimethalin or a 2,4-D, like real strong odor. Like this sales sheet says, be stealth. You don't want to cause a stink. You can add, we have a non-ionic surfactant, which is our Red River NIS, but it's called NIS Pro, and it has odor reduction technology in it. It actually has a scent in it that will mask that harsh smell and make it more appealing to the nose. But this is a sell sheet on it, and there's there's all kinds of different surfactant and adjuvant technologies coming out now. ORTs are new. A lot of the drift reduction technologies that have come out recently are super new technology, and they work really good. That's about all I have. I know I kind of went over that quickly, but we only have an hour. If any of you guys would like some of the slides, the scientific slides or the videos, I'd be happy to share those with you. If you'll send an email to me, I can get those slides to you, those videos, whatever. If you have any questions, submit them to Justin or myself. We'll try to get them answered. Thanks again for attending.